Okay, so let's continue with our next coding exercise series, and we will take this problem, the hurdle race, which is on the hacker rank, and it is also the easy category question. So let's read the question. A video player plays a game in which the character competes in a hurdle race. So what is a hurdle race? So you like there are some hurdles and you have to cross all the hurdles. Hurdles are of various heights, and the character have a maximum height they can jump. So let's suppose you have so many hurdles, so 1 2 3 4 5, so many hurdles, right? And it is the character, so the character who is competing in the hurdle race, so that particular character can have a maximum height they can jump. So there could be some height, only that height that particular character can jump, right? There is a magic uh, portion they can take that will increase the maximum height by 1 unit. But if they eat something, and then they can increase their like jump height, but by only one. So if they take one dose, then the height will be increased by 1 unit. If they take two dose, then height will increase by 2 unit. How many doses of the portion that the character will take to able to jump all the hurdles? And if the character can already clear all the hurdles, just return 0. So we have some array given, height given, and k is the character who can maximum jump of height 1. So let's take one example. So you have some hurdles given, so 5 hurdles, 1 2 3 4 5, and the first hurdle is of height 1, second hurdle is of height 6, third hurdle is for height 3, fourth is for 5, and fifth is for height 2. We have this character k, right? And k can maximum jump uh, of height 4. Okay, and we need to find like can this character can jump all the hurdles? If yes, without taking any dose, then just return 0. If no, then just feed the doses, and how many doses we are going to feed, we need to return that. So let's try that. So when the character will start, it can easily jump the first hurdle, right? Because 4 is greater than 1, so they don't need any dose. Second, can it jumps the second hurdle? No, because the second character can only jump till height 4. The second character can second hurdle, this particular character cannot jump. So we need to feed the doses. So how many doses we need to feed? We need to feed two doses, 6 minus 4 2, so that this will become this will become of height 6, and then this can easily cross it, right? One second, let me minimize a little bit, yeah, so that this can easily cross it. Okay, so till now how many doses we give? Two. Okay, can it like jump the another hurdle? Because now the height is 6. Now the height is 6 because it already took two doses, so the character uh, can jump 6 till 6 height. So can it jump the third one? So the answer is yes, it can jump the third one. The fourth one, yes. The fifth one, yes. So how many like doses it consume? Just two. Okay. So let's took the another one. So we have the character of 7, height 7. Can it jump the first one? Yes. Can it jump the second one? Yes. Can it jump the third one? Yes. Fourth one? Yes. Fifth one? Yes. So how many doses it need? 0. Right? So 0. So that is the only thing like which we want to uh, write a code to find that. So it's very easy, right? So what we are going to do, we will just like run a loop for all the hurdles, because we need to check for all the hurdles whether that particular character can jump for all the hurdles or not, right? So as an example, so let's start from here. It is of height 4, Let me decrease the height little bit. Yeah, it is of height 4 initially. Yeah, so it's for height 4. So what we have to do is we have to return like a maximum number of doses. Second, return the minimum number of doses. Sorry, the minimum number of doses. So minimum number of doses initially 0. Then for I in range of length of height, because we need to like travel all the hurdles, right? Okay, so we know our character can jump till height k. Okay, then we have to check if k is greater than this particular height. We will check if k is greater than I, or better we can check less than I. If k is less than I, if k is greater than I means like this particular the first hurdle height, then it can easily jump. All right, or you can say if k is greater than I, then we don't need to do anything. All right, else what we need to do if k is less than I, or you can say if k is less than I, if k is less than I, so let's suppose, so we started from here, so is k is less than I? No. So it jump, 1 second, it easily jump, right? Now we will, so loop will come here and the second height will be 6. If k is greater than I, so k is 4, I is 6, is k is greater than I? No. So is k is less than I? Yes. So if k is less than I, it can't jump, but so it means we need to feed the doses. So minimum number of doses we need to feed is equal to plus is equal to height minus k. Right, so this is the number of doses like which we need to feed. Right, h minus k, not h, I minus k. um Rather than range for I in, so this is an array, so we can directly run the loop. Okay, we will fix it, but like because here we are taking a range which means 0 to something like that, then in that case we have to take h of I, but I don't think we need to do that. We can just normally say for h in height, so h here, h here, and then h minus k. Okay, so now we feed minimum number of doses 2. Okay, so we feed the doses, so let's feed it. So let's feed it, we give 2 doses, and if we give the 2 doses, the k will become 6. So we need to update the k as well, so k will become the new height. All right, so the new height, so now this can easily jump here. Okay, now check with the next one. If k is greater than h, yes, then pass. Then the next one is greater, k is greater than h, yes, then pass. Is k is greater than h, yes, pass. If k is greater than h, yes, pass. So we need to return the minimum number of doses. Return minimum number of doses. All right. So this is straightforward. So we don't need this condition. We can directly write if k is less than h. All right. So let's try to run the code. First, the sample test cases has been passed. So let's try to run the all the test cases. So all the test cases has been passed. All right. but can we optimize it? Like, it's straightforward, even you don't need to optimize it. But can we optimize it? So answer is yes. See, what we can do is we can find the maximum height of the hurdle, right? Because whatever the maximum height of the hurdle, we will just subtract that in k, and that the number of doses we need to give. So as an example, if it is a height 4, if it is height 4, I don't need to check uh, with all. What I can do is, from all of these heights, from these heights, I can find the maximum height. So maximum height is 6. So what I can do is, so this is the one solution. Just check one by one. What is the another solution? We need to return max of max of 0. So one second. First we need to first we need to find the height. So maximum height, maximum hurdle height is equal to max of height. All right. So we know the uh, maximum hurdle height. All right. Then what we will do is, so in this case maximum hurdle height is 6. So we will, how many doses we will give? 6 minus 4, 2. So how many doses will we give? 6 minus 2, that is the max hurdle height minus k. All right. And then we will return uh, the max of either 0 and the max of hurdle height. So let's try to run the code. If it is works, so let's submit it. So all that has been passed. So you can do this way. So that's, you can save some lines of code, and because max is written in C, so it's maybe little bit faster rather than running a loop and comparing each element one by one. All right. So there are two ways you can do anyway, but anyhow the question is like too easy, so we have done that, right? So that's it. That's the end of the video, and thank you.